Okay, let's go over 5 more of these problems, just to make sure that you had enough practice where you're finding all the zeros. Okay, so first one, this is where we only need a total of 3, and I give you 1, so I give you a 4. So we set up our half box, and we have 1, 3, negative 18, and negative 40 inside. So when you take your quiz, you need to be really good at this process. Just be careful of just simple calculations. You bring down this first number, which is a 1, you multiply, you add, you multiply, you add, and here's how you know you did it correctly. You must get a remainder of 0. So 4 times 10, that's going to give us a 40, which results in a 0. So for this first problem, this first case, what's left over is a real simple quadratic to factor. So we have 1x squared plus 7x plus 10. So it's going to be real easy to factor this. So 2 sets of parentheses. In this case, we know it's plus plus, okay, because everything's positive. So now we just have to quickly think of ways of getting 10. 10 times 1, that won't work because we need it to add up to a 7, this middle term. So we know it's going to be a 5 and 2. Okay, it checks x times x is the x squared. Outers and inners, the 2x and the 5x add up to the 7x, and 5 times 2 is 10. Okay, you've been factoring for a while now, so that's what's considered an easy factoring. Once you see the factors, you know negative 5, what makes this 0, this factor 0 is a negative 5. What makes this factor 0 is a negative 2. Okay, so the one I gave you plus the 2 that we found, that's all 3. We are finished. For the next one, I gave you negative 5 is a 0. We have 2, 23, 80, and 75. So I bring down a 2, I multiply, I add, I multiply. Just to double check, I don't want to make a mistake, so it's negative 65. When we add, we're going to get a 15. And then when we multiply, it's going to confirm that we did everything correctly. We get a 0 as a remainder. Okay, so now what's left over is a quadratic, but it's going to be a little bit harder to factor. Okay, so this is where you will use the AC method. Okay, so the AC method says take the first term and this constant, multiply together. So in this case, 2 times 15 is 30. So I'm going to write a 30x squared up top. The middle term, this 13x, goes on the bottom. So we have to solve this diamond problem. So it's not going to take long. Probably already thought of it. 30 and 1 won't work, 2 and 15 won't work, but a 3x and a 10x is what satisfies this. They multiply, the product is a 30x squared. The sum, though, is a 13. So we're just simply going to rewrite this problem so that I turn this into a grouping problem. So still the same problem, 3x and 10x is still 13x, but allows us to split it down the middle. In this case, we can only factor out an x. So we have a 2x plus 3 in parentheses. We must have the 2x plus 3 on the other side, which means we have a 5 in common. So I'm going to factor out a 5. 5 times 2x is still the 10x. 5 times 3 is still 15. But then the pieces on the outside make up a factor. And then 2x plus 3 is your other factor. So again, whole reason of factoring is so we can see our solutions. What makes an x plus 5 0 is a negative 5. You'll see that it's a repeat. So negative 5 was a 0, but then we count another negative 5. That would be a turning point. When it touches negative 5 along the x-axis, it turns. It doesn't pass through, but then it will cross through. The other 0 is where you set this equal to 0. We have to subtract a 3 and divide by 2. Okay, so again, if you can't do it in your head, write it off to the side and solve for x. Set your factor equal to 0, subtract, and divide. Okay, so 1, 2, 3 answers. That's all we need. That's all we can have because the degree is 3. Okay, this next one, same concept. I give you 1, but this time we're going to end up getting a quadratic that can't be factored. So, and I tell you that number 3 on your quiz, you'll have to use the quadratic formula, just so you're not wasting time trying to factor something that can't be factored. So I bring down the 2, I multiply, I add, I multiply, I add, I multiply, and we're left with a quadratic where don't even bother trying to do the AC method. You can't factor this. So we pick out A, B, and C, and we substitute it into the quadratic formula. And like I said, I'll have the quadratic formula written right on your quiz. So the quadratic formula states opposite of B, so I have a positive 5 on the outside. Make sure you have that plus or minus. And then inside parentheses, I need a negative 5 squared. Make sure negative 5 is in parentheses, or the calculator is going to mess you up before you square it. Minus 4 times A times C, all over 2 times A, which in this case is 2 times 2. And so all we need to do is simplify. So all I'm going to do is ask the calculator what the discriminant is. So I'm going to take my calculator and I'm going to type in negative 5. Remember, don't do square root. I don't want a decimal. So negative 5 squared minus 4 times 2 times negative 5. It produces a 65. And there's your answers. Okay, so you say, why? How's this 2 answers? Remember, it's 5 plus root 65 over 4. That's one answer. And again, we don't need the decimal. Calculator knows what that is. You just leave it in this form. And then 5 minus root 65 over 4. But again, it's okay to just have this. This counts as both answers. Okay, so 2 more problems, 2 more cases that we talked about. Here we need a total of 4 answers. I give you 1. So 1, 2, negative 6, negative 6, and 9 are inside. I bring down the 1, I multiply, I add, I multiply, I add, I multiply, I get negative 9, and then when I multiply and then add, we get a 0. But now we have a cubic, so x cubed plus 3x squared minus 3x minus 9 equals 0. I split it down the middle. I factor out the GCF on the left, which in this case, all I can do is factor out an x squared. I'm left with x plus 3. On the other side, we must have the x plus 3, so you must factor out a negative 3. Okay, negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. So we have factors of x squared minus 3 and x plus 3. And that's all we can do. We can't factor anymore. Now, if this was a difference of a perfect square, we could factor more. But now I'm ready to write my answers. So one answer, the easy answer, is negative 3. So we have 1, we have this negative 3, and now remember this, we have to solve by the square root method. So I have to do the opposite of this, which is a 3, but then I take the square root of 3, and it's up to you to remember a positive root 3 and a negative root 3. So if I list them, I have root 3, I have negative root 3, and I have negative 3 as an answer. So there's all 4 zeros for that quartic function. Okay? Now the last one, it's going to be as easy to factor as number 1, but we're going to have a total of 5 solutions. So this is where you'll see lots of zeros. So when you do number 5, expect this. This was our last case where we have 1, 2, 4, 8, negative 45, and negative 90. Okay, so I bring down the 1, I multiply, hey, there's a 0. When we multiply, we get a 0, then we get a 4, then we multiply, we get a negative 8, but when we add, we get a 0. So I said we're going to see lots of zeros. When we multiply, you get a 0. When you add, you get a negative 45. When you multiply, you do get a positive 90, and then you result in another 0. So again, we should see 5 zeros. 1, 2, 3, 4, 5 when you do number 5. So now this right here is a quartic. So make sure you don't think of this as quadratic. So it's x to the 4th, no cubes, but there's 4x squareds, and then no x's, but then the constant is negative 45. So it's going to be very easy to factor, just like number 1 was easy. The only difference is it's x squared, okay? Since it's a negative 45, I need a plus and I need a minus. And then I'm thinking of ways of getting 45. It won't take long for you to realize 9 times 5, and I need the 9 to be positive, the 5 needs to be minus, or next to minus, so that the outers, a negative 5x squared, and a 9x squared agrees with the 4x squared. That's your middle term. So now I'm ready to do my answers. Just like this one right here, I need to add a 5 and take the square root of 5. So again, root 5, negative root 5 is an answer. Here we subtract a 9, and then we take the square root of negative 9, which you need to remember is imaginary. So the square root of 9 is a 3, but since it was a negative, it's an I. So we have root 5, we have negative root 5, we have a 3i, and we have a negative 3i. Okay, so again, that took less than 11 minutes to do all 5. You will see 5 similar problems when you take your 4-4 to 4-6 quiz. And just make sure you look at over all the homework that we did, the big idea assignments, the warm-ups. You will be more than ready to do well in this quiz. Thanks for watching. Take care.